Hello, this is Pre-Cal Lecture 5.3. What you're going to need for this lecture is a printout, blank printout of your Pre-Calculus 5.3 notes. And you'll also want to have your unit circle handy. All right, to save time, I went ahead and drew out what you're going to be putting on the first two-thirds of your page one of your notes. So go ahead and pause the video, draw this diagram right here on your notes, and then draw this diagram underneath right here in the center of your notes. So go ahead and pause the video and do that. All right, so what we've done is, in the last lecture we talked about only acute angles, but in this lecture, we're going to use a lot of that same information to try to figure out the trig functions for angles greater than 90 degrees. So let's say we have this point xy right here. We went ahead and put it in quadrant 1. Doesn't matter what quadrant you put it in. We're going to work problems where it's in all the other quadrants. And we drew a line from the origin to that point, and we called that distance r. And then we're going to make that into a right triangle. Okay, so we've got y, we've got x, and angle theta. All right, so we can express the length of r in terms of Pythagorean theorem, the square root of x squared plus y squared. And we can express all 6 trig functions in terms of x, y, and r. So for sine, it's opposite over hypotenuse, y over r. For cosine, adjacent over hypotenuse, x over r. And tangent, opposite over adjacent, y over x. So many people learn this with the acronym SOHCAHTOA. Sine opposite hypotenuse, cosine adjacent hypotenuse, tangent opposite adjacent. And then our reciprocal trig functions, we would just flip. So cosecant, we would flip sine, r over y, secant r over x, cotangent x over y. All right, we're going to be using that information. And in addition to that, I want you to, in the center of your notes, we've got this little acronym, All Seniors Take Calculus. You can make up your own ASTC acronym, but I'm going to go with All Seniors Take Calculus, which of course is very much not true. In quadrant 1, all trig functions are positive. In quadrant 2, only sine and cosecant. In quadrant 3, tangent and cotangent are positive, but everything else is negative. In quadrant 4, cosine, so the c, and secant are positive, but all the other trig functions are negative. So you can, what we're going to do is draw a lot of coordinate planes that look like this, ASTC. Okay? And that'll help us determine the sign of the trigonometric functions. All right, so go ahead and pause the video if you need to, and we will go through our notes and work problems. Okay, we are at the bottom of page 1 of your notes, and it says determine the trig functions for theta. And what we're going to do is draw, we've got a point, -1, 3. So I'm going to draw a coordinate plane. You can draw this to the right of the problem if you want. -1, 3, that'd be to the left 1 and up 3. So let's say that looks something like that. We're going to connect that point to the origin. So that is r, that distance r. And then I'm going to make it into a right triangle. Okay, so this distance would be 3. And we're going to do the positive distance of this right triangle. That's 1. All right, the angle that we're looking for, we're trying to get the trig functions between the positive x-axis and this point. All right, so it's not the acute angle, it's this bigger angle, angle theta. All right, so first of all, let's get r. We know that r squared is going to be -1 squared plus 3 squared. So r squared is going to be 10. Therefore, r will be the square root of 10. So we have the hypotenuse. It's the square root of 10. All right, so let's get sine theta. All right, well, our reference angle, what we're going to do is get the trig functions for our reference angle there. We're going to call that alpha, and I know you can't see that. I'm going to draw this whole thing a little bigger, so apologize for that. All right, so this is the point -1, 3. That's r, and we've already figured out that's the square root of 10. We're wanting to get the trig functions for theta. Our right triangle there, we have 3 and 1. So our reference angle is alpha. Okay, so if we can find the trig functions for alpha, then we can use ASTC to determine the sine, because we know that our angle theta is in quadrant 2. Right? That angle terminates here in the second quadrant. And we're measuring from the positive x-axis. So sine theta, first of all, let's find sine alpha. Well, that's going to be opposite 3 over the square root of 10. Okay, so sine theta, all we have to do is adjust for the sine. We know that sine is positive in quadrant 2. We're in quadrant 2. So sine theta is just going to be 3 over the square root of 10. No adjustment needed. All right, well, what is cosine theta? All right, well, let's figure out cosine of alpha first. All right, cosine of alpha adjacent over hypotenuse, so 1 over the square root of 10. However, cosine in quadrant 2 is negative. Remember, only sine and cosecant's positive in quadrant 2. Cosine is negative, so it's going to be -1 over the square root of 10. And then tangent, we're going to figure out the tangent of the reference angle, alpha. That's opposite over adjacent, 3 over 1. Well, tangent of theta, okay, it's this angle, this obtuse angle that's greater than 90 degrees. Tangent is negative in quadrant 2. Tangent's only positive in 3 and 1. Negative in quadrant 2, so it's going to be -3. Now it's easy to get the reciprocals. Okay, the reciprocal of sine is cosecant. We're just going to flip. It's the same sign, root 10 over 3. The reciprocal of cosine is secant. We'll flip that. That'd be -root 10. Flip cosine, so -root 10. And then cotangent, we're going to flip tangent. So cotangent theta is going to be -1/3. So we got all 6 based on we found the trig functions for the reference angle, and then we adjusted the sine based on the quadrants in quadrant 2. All right, let's turn your notes to page 2. Pause if you need to. All right, our instructions for page 2 is the reference angle. Okay, that's what we just talked about that with alpha, is the acute angle made with the x-axis. So find the value of the trig function for the reference angle change the sign as appropriate based on the quadrant. So we're going to do exactly what we did before. So our example is find cosine of 120 degrees. All right, so that you could read this directly from the unit circle, but I am going to show you how it works. All right, here, so let's draw our coordinate plane over to the right. Try to draw it a little bigger this time. 120 degrees is going to be in quadrant 2. Okay, so we'll call, and then our reference angle is the angle. So if this is 0, 90, 180, 270, and then back to 360, what's left is 60 degrees. So our reference angle is 60 degrees. So what we can do is, of course, we're not going to forget our ASTC. What we can do is find the cosine of the reference angle. Okay, so cosine of our reference angle, let's look. The unit circle, cosine of 60 degrees. Remember, it's cosine, then sine. So it's 1/2. So cosine of 120 degrees is going to be, okay, cosine is negative in quadrant 2, so it will be negative 1/2. All right, due to quadrant 2. Cosine is negative in quadrant 2. Let's check the unit circle and see if we did that right. All right, so 120 degrees, negative 1/2, cosine then sine is the right answer. Okay, let's go on to the next one. We're going to find the tangent of 300 degrees. All right, so let's draw a coordinate plane at 0, 90, 180, 270, 360. So 300 degrees is going to be like right here. 30 degrees past. So we want to find the tangent of that angle right there. 300 degrees. Okay, well, first of all, we need to find the reference angle. And the reference angle is this angle, the acute angle, so less than 90 degrees, between the line we've drawn at 300 and the nearest x-axis. And its reference angle is always positive. So reference is going to be 60 degrees because you go from 300 to 360. Reference is 60 degrees. So we're going to find the tangent of 60 degrees and then adjust. Well, you can, if you remember, tangent is just sine over cosine. So sine of 60 degrees over cosine of 60 degrees. All right, and when we adjust, we're going to adjust based on ASTC. We're in quadrant 4, right? 300 degrees in quadrant 4. Tangent is going to be negative there. All right, let's look at your unit circle. The sine of 60 degrees is root 3 over 2. The cosine is 1/2. So tangent 60 degrees is root 3 over 2 divided by 1/2. So that's going to be square root of 3 over 2 times, if we flip the bottom fraction, 2 over 1. Those cancel, and you get the square root of 3. So we've already said it's going to be negative, so tangent of 300 degrees is going to be negative square root of 3 due to quadrant 4. Right, tangent is negative in quadrant 4. All right, we're dealing with degrees now, but we also have to be dealing with radians. All right, so our next example will involve that. So pause if you need to. All right, our example is find the reference angle for 9 pi over 7. All right, so let's get used to radian measures, all right? So we would have 0, pi over 2 radians, pi radians, 3 pi over 2 radians, and then back to 2 pi radians. So 9 pi over 7, if this is pi, 9 pi over 7 is a little past pi, right? So it's going to be somewhere in quadrant 3. That would be 9 pi over 7. So to get this reference angle right here, the reference angle is going to be this little angle right here. So what you would do is you would take 9 pi over 7 minus pi. Okay, so it would be like if we were in degrees, 9 pi over 7 is, I don't know, it's probably roughly 210 degrees, something like that. So you do 210 minus 180. Well, this time's 9 pi over 7 minus pi. Well, that's not very easy to do. Let's change pi into sevenths. So that's the same as 7 pi over 7. That's exactly the same as pi, right? Just multiply it by a clever version of 1, and what is left is 2 pi over 7. So remember, reference angles are always positive, and they're always measured to the nearest x-axis. Okay? It's always going to be acute, so less than pi over 2. All right, on your notes, so in the past, I showed my students an easy way to remember quadrant 1. However, I've decided to move away from that and just really teach the unit circle. I'm going to teach you in the future how to memorize the unit circle, so there's really no point in memorizing this. So just X that out. We will come back in a future chapter to memorizing the unit circle. You're going to get the unit circle on your test, so let's go ahead and move on to the next problem. So find the value of sine 5 pi over 6. Okay, so we're at 0 radians, pi over 2, pi radians, 3 pi over 2, and then back to 2 pi. All right, 5 pi over 6 is just it's in quadrant 2. All right, so that is 5 pi over 6. So our reference angle is what is left. This little angle right here between the nearest x-axis and the line. Okay, so that's going to be just pi over 6. Okay, so we would take pi and subtract 5 pi over 6. So pi minus 5 pi over 6 to get our reference. So that's the same as 6 pi over 6 minus 5 pi over 6. That's pi over 6. But you might be able to, hopefully you could just eyeball that by use the unit circle. So what we're going to do is find the sine of the reference angle. All right, so if you look at the unit circle, sine of pi over 6, sine is the second one, it's a half. We're in quadrant 2. What is sine in quadrant 2? Well, sine, A-S-T-C, sine is positive in quadrant 2. So the sine of 5 pi over 6 is also going to be 1/2. Positive in quadrant 2. Let's check the unit circle and see if we got it right, because 5 pi over 6 is on the unit circle. So look, positive 1/2. All right, so we're good to go there. All right, next one, a little bit different. We want to evaluate sine squared pi over 6 plus cosine squared pi over 4 plus tangent squared pi over 3. What this means is find the sine of pi over 6 and then square it. Okay? So it just means this. So I'm going to write this out. That's what it means. It's just another way of writing it. So plus cosine pi over 4. You take that number and square it. So plus tangent pi over 3. Take that number and square it. This is another way to say that. Okay, sine of pi over 6, we just looked that up on the unit circle on the last one. It's 1/2. And we have to square that. Cosine of pi over 4, find pi over 4 on the unit circle. Cosine is square root 2 over 2. Square it. Tangent of pi over 3. Okay, so you can do sine of pi over 3 over cosine of pi over 3. Okay, so that's going to be square root of 3 over 2 divided by 1/2. So that'd be the square root of 3. So it's going to be the square root of 3 all squared. You can also just memorize pi over 3. Tangent of pi over 3 is root 3. The other one is tangent pi over 6. That's root 3 over 3. So the way I memorize it, if it has the 3 in the denominator, it's root 3. If it's the other one, which is, this is 60 degrees, this is 30 degrees, okay, then it's root 3 over 3. I just kind of memorize that, but you don't have to. You can always do sine over cosine. So this is going to be 1/4 plus root 2 squared would be 2. 2 squared would be 4. And then that's going to be 3. So that's 1/4 plus 2/4 plus 12/4. And that is going to be 15/4. Boom. All right, and let's finish up. We'll look at the last page of your notes for 5.3. All right, so we're using one trig function to find another. So the way that you do it is you determine the quadrant that the angle is in, sketch a picture, use the Pythagorean theorem, and then compute the unknown trig function. All right, so our example for one of these is we want to find sine, and we want to find tangent. We know that cosine is equal to 2/3. That means it's positive. And then cotangent is greater than 0. Both cosine and cotangent are positive, so that can only happen in quadrant 1. We've got to be in quadrant 1 if both of those are positive. So that helps us. Quadrant 1. Now we know cosine is 2/3, so we're going to draw ourselves a triangle. We know that cosine is equal to adjacent over hypotenuse. All right, adjacent is 2, hypotenuse is 3. So we're going to need to get opposite because sine and tangent both involve opposite here. Okay, so Pythagorean theorem, 3 squared is equal, let's call this y, 2 squared plus y squared. So that's 9, that's 4. 5 would be y squared, so the square root of 5 is equal to y. All right, what is sine? Well, sine is opposite over hypotenuse. Square root of 5 over 3. We know it's positive because we are in quadrant 1. Tangent, opposite over adjacent. All right, by the way, this is our theta right there. All right, opposite root 5 over 2. We know that it is positive. So that's how you do it. If it's not one of the famous numbers you see like on the unit circle, like root 2 over 2 or root 3 over 2 or half, then you just draw yourself a triangle. Right? It's just really a little puzzle. So that does it for lecture 5.3, and I will talk to you next time.